My name is Suichi, and we have Santiago who will dive into the demo on how to automate your smart contracts securely today. Just wanted to give a quick intro into OpenZeppelin. We're a security company in the blockchain space. Our mission is to protect the open economy. We work with major players in the industry to help achieve this. We have three main offerings. Many of you know us from our open source smart contract library. We offer audit services, and we built the product Defender, which Santiago will be showing you how to use today. And just to add, our team is growing, so we have some open roles. If you're interested, feel free to apply, and you can apply through Zeppelin/join. That's it from me. I'll let you take the lead.
Thank you, Huichi. Let me share my screen then. Just 1 second. Okay, here we go. As Huichi mentioned, we at OpenZeppelin have three main offerings. Besides our audit services, we also provide the open source smart contracts library, and we also built and released Defender roughly a year ago. So Defender is a platform for securing and automating smart contract operations. The idea is that Defender is a site where you'll be able to interact manually with your contracts, send transactions to them, automate tasks, monitor them, a couple of other things that we'll go through today in a demo. So the plan for today, as a case study, will be to manage a contract that we're going to deploy. We're going to deploy an NFT, an ERC-721, a non-fungible token. The idea will be to manage it, to tweak its roles, who can mint new tokens, who can manage the contract, monitor its activity, and automate the minting of new tokens under certain conditions. To do this, we'll start by writing and deploying the NFT contract. We'll be using the OpenZeppelin Contracts Wizard for this and Remix for compilation and deployment. We'll be creating a hot wallet that will assign as a minter of this contract, assign the minter role to the contract using Defender, and automate the process of minting. Basically, we'll write a small script that will leverage different Defender components in order to mint new tokens whenever we want to. And last but not least, we'll also set up some monitoring for our contract so we can be alerted on certain conditions and even trigger some automated workflows whenever certain events happen on our contract. All in all, we'll be setting up a system like this, in which we'll have our ERC-721 monitored by our monitoring engine within Defender, which will trigger a script with whatever logic we define in it. We'll be using that script for minting tokens, and that script will leverage a private key hosted securely on Defender for minting new tokens. And on the side, we'll also have an administration interface, also part of Defender, for managing the roles within our ERC-721. So let's get started with the first step. So we want to begin by writing and deploying an ERC-721. For that, we'll be using the OpenZeppelin Contracts Wizard. You can just head on to wizard.openzeppelin.com. This is open and free to use. This is just an interface for creating your own contracts. So you have a few already prepackaged, such as ERC-20, 721, or 1155, or a full-on governor contract if you want to deploy governance on chain. We actually have an upcoming workshop about governance tomorrow. I encourage you to sign up. But today we'll be deploying a non-fungible token. So let's say that we want to create the Defender demo token, and we want this token to be mintable using auto-incremental IDs because we don't want to keep track of the IDs outside the contract. And we can also enforce this contract to be possible, so we can pause it in the event of an emergency, for instance. We'll be using role-based access control. So we'll have different roles for pausing the contract and for minting new tokens. So we can keep permissions separate. We'll not make this contract upgradable for now, but we could also do that if we want to. So the idea is that the wizard already sets up all the code for us that we need in order to have a contract with these capabilities, and we can just copy it, download it, or choose to open this directly on Remix. Let's see if this works properly or not. Sometimes I have some issues when there is more than one tab open. Okay, perfect. Here we go. So let me zoom in a little bit. So this has exported the contract directly to Remix, loading OpenZeppelin contracts directly. And the idea is that here we have the contract that the wizard has just generated for us, and we can use Remix for deployment. So we'll use the injected Web3 provider, which is my MetaMask wallet, and we'll choose to deploy the Defender demo contract. Go ahead and run deploy. I'm not sure if you can see the MetaMask pop-up coming up now, but I'm right now confirming that it is transaction on MetaMask. And after a couple of seconds, once this transaction gets mined, we should get our contract deployed on RinkBuy. What we'll do right after deployment is perfect. Here we go. Let me grab the address 03D9, and we'll also verify it on Sourcify, so that we're good citizens and anyone can check out the source code of our contract. This will become relevant in Defender in just a minute. Okay, so we have our NFT deployed on the RinkBuy network. This is a mintable NFT, so whoever has the minter role within the contract can create new instances of this token. And we'll move ahead on to the next step and set up a hot wallet that we'll be using as a minter. By a hot wallet, I mean a wallet that will be used in automated fashion by a script, that whenever the script runs, it will be using this wallet for minting a new token. We're going to create this hot wallet within Defender. So as mentioned, Defender is a platform where you can collaborate with your team and you can define different workflows and build different artifacts that will assist you in smart contract operations. In particular, one of them is Defender Relay. So Defender Relay is a set of keys assigned to your team for sending transactions through Defender. And the benefit of this is that Defender will automate part of the process, but will also secure the private keys that you're using for this. So if we start by creating a relay, let's say that we create a Defender demo NFT minter. We do this on the RinkBuy network. By the way, Defender supports not just Ethereum mainnet, but also Fuse, XDAI, Binance, Phantom, Matic, and Avalanche, as well as all their testnets. For this demo, we'll just go with RinkBuy. And what Defender is going to do here, it's going to create a private key on a secure key vault that's assigned to this relayer, that's assigned to your team, so that whenever you send a transaction using Defender, that transaction will be sent from this Ethereum address. This allows you to grant this address any kind of privileged roles that you need in your system. For instance, we'll grant this address the minter role, so it can mint and create new tokens in our contract. We'll go ahead. Note that Defender is creating an API key and secret. The secret is not the relayer private key. It's just think of this as a user password that you can use for sending transactions via this relayer. So if we want to interact with our contract, we could do it directly here from Defender's UI. So for instance, we could choose to send a transaction to, let me grab the address real quick once again. And we could send a transaction using this private key directly here from Defender. So for instance, we could choose to, I don't know, try minting a new token to an address we control. This would probably fail because the relayer doesn't have minter roles yet. Indeed, access control is telling us that we don't have the necessary rights to do this. But as mentioned, the idea for Relay is not to send transactions manually, but to automate this as part of a process. And for automating this, we have created an NPM package called the Defender Relay Client. This is a small NPM package you can use, either standalone or integrated with Earth.js or Web3.js for sending transactions through the relayer. So you can just you can create a new relayer client using the API key and secret that Defender generated for you. By the way, you can rotate this API key and secret as much as you need while retaining the same private key. This is the same sending address. And whenever you send a transaction, instead of this transaction being signed locally on your workstation, This request will be sent to Defender, where Defender will validate the transaction. It will assign a nonce to it, so you can have multiple processes using the same relayer without having to worry about nonce clashes. It will decide what's the best gas price for sending a transaction based on the speed that you choose. It's going to sign the transaction with the private key stored on the secure key vault, and then it's going to broadcast the transaction through several different providers, so that if any provider is down, your transaction will still make it on chain. And after the transaction is sent, Defender will keep monitoring the transaction and will resubmit it with increased gas price if needed until it actually gets mined. You have a couple of things you can customize. You can choose the speed. You can query the status of your transaction. You can replace transactions if you want to. You can use this integrated with Ether.js as a signer object. You can also use it together with Web3.js. You can define a time to live for transactions. You have a couple of you have several settings that you can choose that you can review here on the documentation. So what we can do is we can set up a script, which I have written here in the gist, that basically takes care of this, takes care of using the relayer for minting new instances of a token in our contract. So what this script takes care of is it's using the Defender Relay client integrated with Ether.js to get a signer object and a provider object. This provider will be used for running queries to the Ethereum network via Defender. So you don't need to get your own access to the network by by managing your own nodes or setting up an API key for any provider. You can do everything within Defender. And basically all you need to do is create both a provider and a signer object using these API key credentials that Defender generated for you. And from there on, since we are integrating with Ether.js, this is a regular Ether.js script. You just create a new instance of an Ether.js contract using the address of the contract you have deployed and its API, and you just send a transaction as you would normally do. And the difference here is that this transaction, instead of being locally signed, will be signed and broadcasted by your relayer on Defender, so you don't have to worry about that. Now I could run this code locally, for instance, in a shared server I have, configured with the cron, so this runs regularly or connected to other parts of my system, or I could have Defender run this code for me. And that's exactly what we're going to do by setting up an autotask. So autotasks are code snippets. Think of them as Lambda functions where you can define your own logic that are tightly connected with other parts of Defender. So here we'll create a Defender demo NFT, let's say mint Defender demo NFT. We're going to trigger this on schedule. So let's say we want this to run every 10 minutes. So every 10 minutes, a new NFT will come into the world. And we'll connect this to the Defender demo NFT minter to the relay we have just created. And we'll use the code that we just got from the autotask. I'm going to replace here the address with the one that we have been working with. Here we go. And this recipient is just an address under my control. So what's going to happen is that every 10 minutes, Defender is going to run this code, which will connect to the relayer we have specified. In this case, since we're connecting the autotask to the relayer directly within Defender, we don't need to provide any API keys. Defender will take care of connecting everything on by itself. So whenever you send the transaction will go through the address of the relayer you have defined. Note that instead of triggering this autotask on schedule, you can also choose a webhook, which will return a public URL that you can use for triggering the execution of this code by integrating it with other system or even exposing it on your front end. So we're going to go ahead and create this autotask. By the way, Huichi, do we have any questions so far?
No, not yet.
Awesome. Okay. So we can, as mentioned, we can run an autotask manually or trigger by a schedule or by a webhook, or, well, we can do this manually whenever we want for testing the autotask. This run should fail because we don't have the necessary permissions for actually running this. As we can see, we're getting an error that the transaction may fail or require manual casing. This is a native error from Ether.js. So we're going to go back to our agenda and go on to the next step, which is assigning the minter role to the relayer we have just created. For doing this, we're going to use Defender Admin. Defender Admin is another component, which is an interface for managing your contracts, for running administrative actions on your contracts. Defender Admin does not hold any kind of rights over your contracts. You still own the private keys that control them. But the idea is that this acts as an interface so you can create new proposals, review them, and approve them in collaboration with your team without having to write any custom scripts for doing that. So we'll go ahead and start by importing a new contract. This is going to be the Defender Demo NFT, which lives on Brinkby and sits at this address. So Defender will validate that indeed the contract exists at this address. It's going to pull the ABI from Sourcify because we have previously verified it. It's going to detect a couple of features on this contract. For instance, it's detecting that this contract is not upgradable. If we had used the upgradability plugins for Hardhat or Truffle that we provide as part of our open source offering, then Defender would recognize that this was an upgradable contract and allow us also to upgrade it from within admin. It will detect that it's possible. So we'll have some simplified actions for pausing the contract in the event of an emergency. We'll go ahead and add it to Defender. Note that, again, we're not making any changes on the contract. The contract is still owned by us. And by us, I mean by the deployer account. So admin is acting just as an interface for management. In terms of management, what we're going to do is we're going to create a new admin action, which is calling a function with different execution strategies that we're going to see in a minute for administrating our contract. So what we're going to do, we're going to call the grant role function. We're going to use the minter role defined in the contract, and we're going to use the Defender Demo NFT minter relayer that we had just created. Now we're going to run this directly from our externally owned account. This is the address we have right now on MetaMask. But we could also pick some more interesting workflows. For instance, we could run this through a multisig, for instance, such as a Nosy Safe in case that this contract is owned by a multisig in production. We can also throw in a time lock in between. So if we want to enforce a delay between this action being executed, this action being proposed and being executed, we can do so using a time lock controller from the OpenZeppelin contracts library. Alternatively, we can also use a governor contract. So we can have this proposal be voted on chain by, let's say, all holders of your project's token. And we can also add a multisig on the front of that. Anyway, we have a bunch of different options for choosing how we want this proposal to be executed. Now, since the address I have on MetaMask is the admin, I can just execute it directly from this externally owned account. I'm also going to provide some information on this, such as granting minter role to relayer in order to get the Autotask running. So the idea is that you can provide some information so that your team can review the action you're proposing. And for instance, if these require multiple approvers because we're going through a multisig, they could use all this information here for understanding the context and deciding whether they want to approve it or not. So any member of your team that has access to your team on Defender can come here, can review the pending proposals. And in this case, since we are the owners of the account that can execute it, we're going to run this directly from MetaMask. Remember, if this were a multisig, for instance, here we would be collecting signatures by the different signers of a multisig. So we have just sent this transaction. As soon as it gets mined, what should happen is that our relayer should now have minter rights on our NFT contract. So if we go back to our Autotask, to the mint Defender Demo NFT, which is connected to the Defender Demo NFT minter, we see that we had this manual run from a couple of minutes ago that failed. If we run again, hopefully now this should succeed and we should be minting the first instance of the token. So here we see that we are using the relayer we had just created. and we minted an NFT for an account on this transaction. If we go to Etherscan, we see that this transaction is pending, that it was indeed sent from our relayer. So this transaction was sent from Defender using a private key stored in a key vault managed by Defender. That way, you don't need to worry about how you secure and how you protect your private keys. And it was sent to the contract that we had just deployed. So let's try refreshing, and we see that indeed we have minted token ID 0 of the Defender demo token. Okay, so we're at the part where we have deployed our contract, we have created a hot wallet, we have set up a script that's going to be run by Defender that uses the hot wallet for minting new tokens. We're going to go on to the last step, and we're going to start monitoring our contract as well. For that, we're going to use another Defender component, which is Defender Sentinels. A Defender Sentinel is a monitor set up on a contract that you control, or that you don't control, basically any contract on chain, where you define certain conditions that you want to observe on your contract. So we'll go ahead and create a Sentinel for Defender demo NFT transfers. We're going to monitor our contract on RinkBuy. This is the Defender demo NFT. I'm on the right one, right? 3D9, just to double check, yeah, 3D9. And we're going to create a Sentinel that just requires one block of confirmation. For production, you can choose between 1 confirmation or 6 confirmations in case you want to be more resilient to reorgs before you trigger an alert. The next step is deciding which transactions that affect this contract we're interested in. So we can define conditions, for example, on the value of the transaction, or we can define conditions on the gas price. If, let's say, we only want to monitor transactions with a relatively high gas price, or transactions that succeeded as opposed to failed transactions. And here, basically, we can define any conditions on the transaction itself, and also on the event that this transaction triggered. So here we'll be interested on transfer events. We want to monitor whenever a token is sent from one user to another. And in order to restrict the kind of transfers we're working with, we're going to ensure that the sender is not the 0 address. So whenever an NFT is minted, a transfer event is emitted where the sender, where the from address is the 0 address, which means that that NFT instance came into existence. We're not going to look for minting events. We just want to see transfers between 2 different users. So we're going to tell Defender that we want transfer events where the sender is not the 0 address. We could also wire this to an autotask, so we could define any custom logic that we want for deciding whether a transaction should be picked up by a Sentinel or not. And we can also test this. For instance, we could choose a specific block or transaction and ask Defender to try to match that block against the conditions we have here to simplify debugging of the Sentinel conditions. The last step is deciding what we want to happen whenever one of these transactions is picked up. For instance, we can choose to send an email or a message via Discord. We can also send messages via Slack or via Telegram, or send the information to Datadog so we can later aggregate all this data. And we can also choose to trigger an autotask in response to this. So what's going to happen is whenever there is a transfer between 2 users in our token, we're going to execute the code that's going to mint a new instance. So whenever users send their NFT to each other, a new NFT will be minted. We can also fine-tune the conditions for firing the Sentinel. For instance, we can choose to execute this only if there are 10 occurrences of any of these transactions within 15 minutes, or to wait a specific amount of time between 2 iterations of 2 times that the Sentinel fires. But for now, we'll go with a simple configuration. Okay, so now Defender is monitoring all transfers of NFTs on our contract. We could use any NFT-aware wallet for transferring an NFT and triggering this. But for the sake of it, we're going to do it using admin once again. I'm just going to create a new admin action for transferring the token. So, oops, sorry. So what I'm going to do is create an action that will transfer token ID 0 from my wallet to an external wallet. Okay, so let's go with a transfer from. We don't want it to be safe. And this is going to go from my EOA to another EOA, just for the sake of testing. And we're going to move token ID 0. And we're going to do this directly from the EOA. Okay, and this is just going to be transfer token 0. Okay, so in this case, we're just using admin as a wallet. It's not particularly interesting, but for instance, let's say if this NFT was held in a multi-sig, we could be using this for interacting with the multi-sig and having it send the transfer transaction to the NFT contract. Okay, so we have sent the transfer transaction. What should happen now? Well, we can see that it was sent from our wallet directly. So what should happen now is that we have basically closed the loop. And now that we have transferred a token instance, this will be picked up by the Sentinel we have configured, which would be sending us an alert via email and Discord. It's also going to trigger the minting autotask. That's going to use the relayer we created, which basically holds the private key with the rights to minting. And the relayer will take care of sending the transaction back to the NFT contract in order to mint a new instance. And the relayer can do that because we used admin before for granting this private key minting rights over our contract. So for instance, if we go to Discord, we see that here on the channel that I have set up for this, the Defender demo NFT trigger, Sentinel was triggered, linking us to the transaction that was executed along with all the information about the transaction that was sent that triggered the Sentinel. And we can also go back to Autotasks and check out the Mint Defender demo NFT Autotask that we created just a couple of minutes ago, and we see that 1 minute ago, triggered by a Sentinel, we have an execution that minted a new NFT in a transaction. And this transaction, if we inspect this on Etherscan, we see that it was sent from address 89AC, which again, 89AC corresponds to the relayer we had just created on the RingPay network. So again, to wrap up, what we did is we created a new contract using the contracts wizard and deployed it directly using Remix, and set up Defender so that actions on this contract were monitored. In particular, transfers between two users were picked up by the Sentinel. We get an alert on that via Discord. You can set up Sentinels for any kind of alerts. You could use that for alerting of administrative actions for example, whenever a new role is granted or whenever your contract is upgraded, or if you spot a transfer on an ERC20 for a ridiculously high value or with very, very high gas price and you want to be notified on it, you can define all of that within Sentinel. You can also define what you want to happen. You can just get an alert via different channels, or you can execute your own code supplied from an autotask to decide what happens. Autotasks can do basically anything you can express in code, not just sending transactions via relayers. You also have a secrets vault with autotasks, so you can add any API keys for connecting to external services that you control. And you also have a small key value store that you can use for persisting information between autotask runs. So again, you can define whatever logic you want in the autotask, and you can have it run on a schedule basis, such as for updating an oracle or running liquidations or whatever you need on your system. Triggered by a webhook, so you could use it for exposing that autotask to the front end and use it as a meta transaction relayer, for instance, or you could have it executed by a Sentinel, so it acts as a reaction to any kind of transaction you see on your contract. And as mentioned, the autotask is tightly coupled with relayers that not only takes care of securing your private keys, but also simplifies the process of sending transactions by automatically assigning nonces, choosing high prices, and managing resubmissions for you, so you don't have to worry about that. And last but not least, we have admin for running administrative operations on your contracts, either directly or via a multi-sig or a time lock or an on-chain governance contract. The last part of Defender that we want to share today is Defender Advisor. Advisor is a knowledge base of security best practices where we have loaded information on development, testing, monitoring, or operations on smart contracts, where you can look for any topic you're interested in, such as reentrancy, and check out all the articles that we have loaded here on information on this particular vulnerability, the security controls you want to implement, the patterns that you have at your disposal, code samples on how to protect against this, and basically all the information you need to make sure your code is secure. This doesn't replace an audit, but it should give you some good pointers on what kind of controls you want to take care when both developing and operating your smart contract system. So that's it for today. We have covered a little bit of OpenZeppelin contracts and wizard and all different components in OpenZeppelin Defender.